The rule of railway engineering said a locomotive had to make sense. It had to fit the established template. Wheels in the right places, power delivered the right way, fuel burned in the right order. Engineers knew what a locomotive was supposed to be. These machines disagreed. One moved with no pistons and no cylinders. Another burned fuel so corrosive it destroyed itself from the inside. A third was assembled from the salvaged remains of three completely different machines. These were not accidents of ignorance. They were answers to questions nobody else dared to ask. Here are 10 weird locomotives. Engineers still struggle to explain. Number 10. The GM Aerotrain. This was the first and only time a major American railroad experiment used highway bus bodies as its primary passenger structure. Every passenger locomotive before, it was built on purpose-engineered railway frames. The Aerotrain threw that out entirely. General Motors mounted modified bus bodies onto rail undercarriages and put a 1,200 horsepower EMD 567C diesel engine at the front, the same engine type used in city transit buses, and called it the future of American passenger rail. The problem driving it was real. By the mid-1950s, American railroads were losing riders to automobiles and aircraft at a rate that threatened the entire passenger business. General Motors built 2 complete train sets in 1955, offering railroads a cheap, modern-looking train without the capital cost of purpose-built equipment. Both sets entered revenue service. Union Pacific ran one on its City of Las Vegas route. Rock Island used the other on Chicago to Peoria service. They remained in operation until 1966. One complete set is preserved at the National Museum of Transportation in St. Louis, Missouri. The second is at the National Railroad Museum in Green Bay, Wisconsin. The Aerotrain proved that a locomotive built from bus parts could enter mainline revenue service. It just could never convince anyone it should have. Number 9. The Pennsylvania Railroad S2 steam turbine. In 1944, a steam locomotive arrived on the Pennsylvania Railroad that had no pistons, no cylinders, no crossheads, and no main rods. Every steam locomotive ever built before, it drove its wheels through reciprocating motion, pistons pushing rods, rods turning crank pins rotating driving wheels. The S2 used a steam turbine geared directly to the driving wheels and nothing else. Baldwin Locomotive Works built the single prototype in Eddystone, Pennsylvania. It ran on a 686 wheel arrangement, a configuration that had never existed before and has never been used since. Its forward turbine produced approximately 6,900 horsepower. The 68-inch driving wheels turned without a single connecting rod attached to them. The Pennsylvania Railroad wanted smooth, vibration-free performance at high speed on its premier passenger corridors, believing a turbine could deliver what reciprocating machinery never could. In testing on PRR mainline assignments, it did exactly that. It was also consuming fuel and water at rates so far beyond any economic threshold that no railroad could absorb them. The S2 was retired in 1949 and scrapped. No buyer was found. No museum acquired it. Nothing survives. A machine that worked exactly as designed and still could not survive, because designing out the piston also designed out any hope of competing with diesel. Number 8. The Norfolk and Western John Henry. How do you fight a diesel-electric locomotive using the fuel the diesel is trying to replace? That was the question Norfolk and Western answered in 1954 when Baldwin Lima Hamilton and Babcock and Wilcox delivered the John Henry, a steam turbine electric locomotive that burned coal at 600 pounds per square inch of boiler pressure, drove a turbine, spun a generator, and powered electric traction motors. It weighed 818,000 pounds. It was rated at 4,500 horsepower. The railroad named it after the folk hero who raced a steam drill and won only to die from the effort. Norfolk and Western had structural reasons to try. It hauled coal over its own lines. Its shop forces were among the finest steam maintenance crews in the country. If a coal-fired turbine electric could match diesel on operating economics, the railroad could power its heaviest trains on fuel it effectively controlled. Tested in coal drag service on NW's mountainous main line, it performed adequately in tractive effort terms. Its water and fuel consumption made sustained operation impossible. After approximately 3 years of testing, the John Henry was retired in 1957 and scrapped. Norfolk and Western ordered its first diesel locomotives that same year. They named it after the man who beat the machine, and then died. And the locomotive earned both halves of that story. Number 7. The New York Central M497 Black Beetle. The rule was simple. Railroad motive power came from steam, diesel, or electric traction. Nobody said anything about jet engines from a Cold War bomber. In 30 days in the summer of 1966, the New York Central Railroad changed that. Don Wetzel at NYC's Technical Research Center led a team that took a standard Budd RDC-3 commuter railcar, originally powered by two 275-horsepower Detroit diesel engines, and mounted two General Electric J4719 jet engines on the roof at the front. These were surplus engines pulled from a Convair B-36 Peacemaker bomber. The original diesels were disconnected from the wheels, but kept running to power the air brakes and electrical systems. Ruth Wetzel, a commercial artist, designed the streamlined fiberglass nose cone that gave the car its aerodynamic profile. On July 23, 1966, with Don Wetzel as pilot and NYC President Alfred Perlman in the co-pilot seat, the M497 ran a 21-mile stretch of straight, unmodified track between Butler, Indiana, and Stryker, Ohio. It was officially clocked at 183.85 miles per hour, setting the American rail speed record. Wetzel later disclosed the speedometer had peaked at 196 miles per hour before he reduced power. As a precaution, railroad ties had been placed across the track near Toledo to derail the car if it ran away. The jet engines were later removed. The rail car returned to commuter service and was scrapped in 1984. A commemorative plaque was dedicated at Bryan, Ohio. 30 days of work, one afternoon on the tracks, and a speed record built from bomber surplus and a commuter car. Number 6. The Union Pacific Gas Turbine Electric Locomotive, Big Blow. This was the most powerful single-unit locomotive in the world when the third generation was delivered, 8,500 horsepower per complete unit, and it burned fuel that had the consistency of cold tar at room temperature. Every other American railroad in the late 1940s and 1950s was buying diesel electrics. Union Pacific chose gas turbines instead. A gas turbine locomotive replaces the diesel engine with a turbine. Power plant output driving a generator powering electric traction motors. And its advantage is enormous horsepower from a compact installation. Union Pacific's fuel of choice was Bunker C heavy fuel oil, a petroleum byproduct so viscous it had to be heated to 200 degrees Fahrenheit before it could be pumped into the turbine. General Electric built 55 gas turbine electric locomotives for Union Pacific in 3 generations, between 1948 and 1961. At their peak, the fleet hauled approximately 10% of the railroad's total freight traffic, the largest gas turbine locomotive fleet ever assembled by any railroad on Earth. Railroad workers nicknamed them Big Blows because turbine exhaust was deafeningly loud. Soot buildup and blade erosion from corrosive ash in the heavy fuel oil plagued the fleet throughout its service life. Rising fuel costs and the availability of high horsepower diesels ended the program. The fleet was retired between 1963 and 1970. One third-generation unit survives at the Illinois Railway Museum. They burned what refineries discarded, produced more power than anything else on rails, and destroyed themselves slowly from the inside. Number 5. The Chesapeake and Ohio M1 Steam Turbine Electric. Railway operators had a problem in the 1940s. They wanted the energy density of coal and the smooth, controllable power of electric traction motors, and no existing locomotive gave them both. The COM1 was built to solve that. Baldwin Locomotive Works and Westinghouse Electric delivered 3 units between 1947 and 1948. Each used a coal-fired boiler operating at 310 pounds per square inch to generate steam that drove a turbine that spun a generator that produced electricity for traction motors. A steam locomotive that drove its wheels with electric motors, with no mechanical connection between the boiler and the wheels. Each unit measured over 154 feet long with its tender, making them among the longest steam locomotives ever constructed. The locomotive alone weighed approximately 856,000 pounds. Rated output was 6,000 horsepower. The CO planned to use them between Washington, D.C. and Cincinnati, Ohio. From the first days of service, the M1s consumed extraordinary amounts of coal and water, demanded intensive maintenance, and proved unreliable in the turbine electric drive system. Railroad workers called them sacred cows, machines that cost a fortune and produced very little useful work. All 3 were withdrawn by 1950, less than 3 years after delivery. All were scrapped. None survive. The M1 proved the concept of turbine electric drive on a steam platform was technically coherent and operationally catastrophic. 2 facts that do not cancel each other out. Number 4. The British rail class 55 Deltic. Conventional diesel engine design used upright cylinders, pistons moving vertically, and a crankshaft at the bottom, a layout every diesel engineer in the world understood and could service. The Deltic used none of that. The Napier Deltic engine was an opposed piston 2-stroke diesel built around a triangular arrangement of 3 crankshafts and 6 banks of cylinders, with pistons moving toward each other from both ends of each cylinder. No cylinder heads, no conventional valve gear. A layout that looked less like a locomotive engine than an abstract mechanical sculpture. Each Class 55 locomotive contained 2 of these engines, producing a combined 3,300 horsepower, the most powerful single-unit diesel locomotives in the United Kingdom when introduced. Each locomotive contained 36 pistons total, arranged across 3 banks of 6 in each engine. The Deltic engine was originally engineered for Royal Navy fast patrol boats. English Electric adapted it for railway use at their Vulcan foundry in Newton-le-Willows, producing 22 locomotives between 1961 and 1962. They were assigned to the East Coast Main Line between London King's Cross and Edinburgh, hauling the fastest express passenger services in Britain and sustaining 100 miles per hour with heavy trains for 21 years. Think of it this way: more pistons in one locomotive than in 7 typical car engines combined, packed into a space roughly the size of a large garden shed. The Deltics were withdrawn in 1982, replaced by intercity 125 high-speed trains. 6 have been preserved. Several remain operational on heritage railways in the United Kingdom. A triangular crankshaft arrangement designed for patrol boats ran the most prestigious passenger expresses in Britain for 2 decades and made it work every time. Number 3. The Union Pacific Experimental Coal Turbine Locomotive. Railway operators accepted one constraint as absolute: gas turbines burned petroleum. The idea of burning solid coal in a gas turbine was considered mechanically incoherent. In October 1962, Union Pacific assembled a locomotive in its own shops from the salvaged components of 3 entirely different machines: a modified Alco PA-1 passenger diesel cab unit, the chassis of a former electric locomotive purchased for scrap, a turbine prime mover pulled from a retired first-generation gas turbine unit, and a tender from one of its own steam locomotives. The combined machine ran on 18 axles with 12 powered, producing approximately 7,000 horsepower total from the turbine and the retained diesel engine together. The purpose was specific: test whether pulverized coal, fed into the gas turbine as powder, could replace petroleum. Coal was Union Pacific's most plentiful on-line commodity. If it worked, the railroad could power its most capable locomotives on fuel it effectively controlled. The turbine ran on coal powder. The locomotive moved under coal turbine power. It hauled real freight trains. Coal ash caused catastrophic erosion of the turbine blades, shortening their service life to a fraction of what petroleum operation produced. Soot and slag fouled every component in the hot section. In 20 months of testing, the locomotive ran fewer than 10,000 miles. The project was declared a failure in 1964. The locomotive was retired and disassembled. No components are known to survive in preservation. For a brief period, a machine built from salvage ran on powdered coal and hauled freight, the most extreme locomotive experiment in American railroad history. Number 2. The Pennsylvania Railroad Q2 duplex freight locomotive. In the spring of 1945, at the PRR's Altoona test plant, locomotive number 6175 produced 7,987 indicated cylinder horsepower. That figure is the highest ever recorded for any steam locomotive on a static test plant. It has never been equaled. The established rule of steam freight locomotive design said more tractive effort meant more driving wheels on a longer rigid frame, with one set of cylinders driving one chain of coupled drivers. The Q2 split its driving wheels into two independent groups, powered by four separate cylinders on a single rigid frame, the duplex arrangement, and in doing so, reached a power figure no other steam locomotive has touched in nearly 80 years. The PRR's Juniata shops built 26 Q2s between 1944 and 1945. The wheel arrangement was 4-4-6-4. Tractive effort was 115,800 pounds. The railroad claimed a Q2 could haul 125 freight cars at 50 miles per hour, representing 78% greater capability than any previous PRR freight locomotive. Consider what 7,987 horsepower means. The equivalent output of more than 100 full-size pickup truck engines running simultaneously at maximum load, generated by one machine on a test plant in 1945. All 26 Q2s were retired by 1951 and scrapped by 1956. Not one was preserved. 2 number plates and 1 builder's plate are the only physical objects confirming the most powerful, rigid-frame steam locomotive ever built once existed. The record stands in a test ledger. The machine does not. Number 1. The Norfolk and Western Y6B compound articulated locomotive. The rule, accepted without serious challenge by every major American railroad by 1948, was that steam was finished. The diesel-electric had won. Any further investment in steam technology was economic irrationality, dressed up as engineering. Norfolk and Western did not accept it. While every other Class I railroad in America was canceling steam orders and signing diesel contracts, NW was still building brand new steam locomotives at its own Roanoke shops. Not compromises, not holdovers, but the most technically refined compound, articulated locomotives ever constructed for American freight service. The Y6B used a 2882 wheel arrangement on an articulated frame. Steam was used twice before exhausting, first through high-pressure cylinders, then again through larger low-pressure cylinders, extracting more work from every pound of coal burned. Starting tractive effort in simple expansion mode reached 152,206 pounds, among the highest figures ever recorded for any steam locomotive in regular mainline service anywhere in the world. The Y6B was built at NW's own Roanoke shops between 1948 and 1952 without outside locomotive builders. The railroad had structural advantages no competitor could replicate. Cheap coal from its own lines, shop forces who could build steam more efficiently than any contractor, and a physical plant designed from track to maintenance facility to operate steam. NW's Y6 class fleet, operating alongside its Class A fast freight locomotives and Class J passenger engines, kept the railroad competitive against fully dieselized competitors until 1960, a full decade after every comparable railroad had abandoned steam, hauling coal tonnages that made Norfolk and Western one of the most profitable railroads in America through the 1950s. The Y6B's starting tractive effort, 152,000 pounds of pull, is roughly the equivalent weight of 40 fully loaded semi-trailer trucks, delivered at walking pace up a mountain grade with a coal train stretching out behind. Steam retired from NW in 1960. Several Y6 class locomotives survive in preservation. Number 2156 is displayed at the Virginia Museum of Transportation in Roanoke. Number 2050 is at the BO Railroad Museum in Baltimore. The Y6B broke the biggest rule of the post-war railroad era. Not a rule about wheel arrangements or fuel or cylinder design, but the rule that said the age of steam was over. And it proved that rule wrong for 12 years before finally stepping aside. The machines on this list were not built by people who ignored the rules. They were built by people who understood exactly which rules could be broken and why. Some failed. Some set records that have never fallen. All of them exist because an engineer looked at the accepted answer and decided it was not the only one. That instinct to question what everyone else agreed on is what moves the entire history of railway engineering forward. If you want to see more, click the video on screen now.